Hello all and welcome to the latest and last instalment of the raw materials section in the BPF and PCN's product lifecycle series. Unfortunately, Pravin couldn't be here in person due to unforeseen circumstances, so he's kindly sent us over a voiceover presentation. If you have any questions, do reply to the email as normal, and I will send them over to Pravin to answer in due course. Apologies again, so I'm just going to press play and it should load perfectly.
Good afternoon, ladies and gentlemen. My name is Pravin Mistry from Priya Limited. In this series, I'm going to discuss formulating thermoplastic master batch and compounds. When designing formulations, following consideration needs to be taken. For example, what's the end application of the product? Formulators are usually the second or third tier suppliers in the chain. Molders might be only supplying a small part of the finished product. If the wrong base polymer is used, then this could result in product failure, costing the company and exposure to possible liability. Also, we need to take into account the mechanical and chemical properties required. We also need to work out what sector the product will be used in. Is it going to be used in food, pharmaceutical, medical, or automotive? We also need to look at the different types of formulations that will be used in what applications. Is it going to be in food, contact products, or is it going to be used in industrial products? Other questions you might be asked: what's the polymer choice for the compound? What's the processing temperature and the dwell times of the manufacturing process? Does the end product need to be protected from high temperature? How important is the light fastness and weather fastness? If the product's going to be used outdoors, what country? What's the life expectancy requirement of the product? Also, we need to take into consideration the toxicity requirements, any kind of food contact, human body contacts, toys, etc. We also need to look at wall thickness of the end application, requirements from the customer or customer's customer, types of filler, additives, etc. When looking at additives, there's a variety of additives that can be used. We'll just discuss a few here. Some additives are used to improve output rates, such as processing aids, common one being fluoroelastomer. The same additive can also give better mold release in injection molding and also help melt fracturing blown film applications. Other additives like UV stabilizers, they can help to prolong the life of the base polymer. Typical application is stadium seats in football grounds, when helping them to prevent seats from becoming brittle or being discoloured in a short period of time. UV absorbers can also be used as another type of additive in conjunction with UV stabilizers to offer polymer protection. Antioxidants. These are more commonly used to prevent polymers from undergoing thermal degradation while being processed or when in contact with heat over a long period of time. Other properties like low friction, impact strength, viscosity, antibacterial, conductivity, and antistatic. These can be used to increase the performances of the end product as well. Fillers are often used to modify the properties of compounds of the base polymer. In some cases, they're just used to reduce the cost, the most common ones being calcium carbonate, magnesium silicate, mica glass beads, and fibers, and also barium sulfate. The level of filler that can be incorporated into these compounds can be as much as 80% in some cases. Calcium carbonate, like I say, is the most common one used to reduce the cost. Talc is also used to increase the rigidity and deflection temperature and enhance the properties such as thermal conductivity and lower cycle times. Mica's got a good sound deadening properties. Glass beads can also be used to lower the frictional properties of the base polymer. Glass fibre is often used to reinforce polymers such as nylon and polypropylene. When When it comes to colouring the formulation, there's three main types: inorganic pigments, organic pigments, and dyes. Inorganic and organic pigments are finely divided solid particles which become insoluble particles when mixed within the polymer. Dyes are often designed to dissolve into the polymer. However, dyes don't have such a wide compatibility with polymers when compared to inorganic and organic pigment types, and their migration resistance, especially in high concentration, is often inferior. Inorganic pigments, they tend to be less vibrant, and the tint strength is a lot lower than organic pigment and dyes. The inorganics, they usually have excellent migration resistance, they've got higher heat stabilities. For example, ultramarine blues, chromium oxide greens, and red shade iron oxides can all withstand temperatures in the excess of 400 degrees C. That's enough for most of the polymers these days. Light and weather fastness is also excellent, and they've got very little influence on warping behaviour. In most instances, they have excellent chemical and solvent resistance, even when used in low concentrations. They're very easy to disperse into the main polymer as well. Organic pigments are strong, vibrant colours with very good tint strength, and the migration resistance is usually very good. Then again, there are exceptions to the rule. There's many organic pigments where the heat stability can be up to 300 degrees C, but others can be as low as 180 degrees C. Warpage can be a major problem when formulating with organic pigments. However, there are quite a few organic pigments where the warpage is considered to be low and small. There is a small selection where it's believed that there's no influence on warping behaviour whatsoever. Chemical and solvent resistance is usually quite good with organic pigments, but some commonly used organic pigments are known to interact in a negative way, so you need to be careful when formulating. Usually, if there is a negative interaction, this can usually be seen as shade variation. Sometimes it can be difficult to disperse organic pigments in high concentrations. When looking at dyes, dyes are normally strong, vibrant, transparent colours with good tint strength. Usually the migration resistance can be very good. Then again, there are exceptions to the rules again. But if the dyes are used in higher concentrations than what the manufacturers recommend, they do have a tendency to migrate. Most dyes have got good, excellent heat stability, some in the excess of 320 degrees C. Though then most of them tend to be around 240 to 300 degrees C. The light and weather fastness is variable. Light fastness is measured on different scales. Dyes have no influence whatsoever on warping behaviours, and chemical and solvent resistance is usually very good. In summary, when formulating thermoplastic compounds, master batches, etc., it's essential that you choose the right polymer, the ingredients, additives, etc. for the actual application. Always ask the customer what they're expecting from the compound. For example, if you're formulating a red compound with a 5-year life expectancy for a stadium seat in the UK, it will be completely different to one of that in Saudi Arabia. Also, opacity is another important factor you need to take into consideration when making any compound colour. Adding more pigment than necessary can considerably increase the cost, so you need to be careful. Also, mechanical and electrical properties can also be affected if too much pigment is added. It's also important to check what effect the pigments you choose have on the properties of the compound. If you don't disperse any of the pigments, it can affect properties like impact strength, tensile strength. In some cases, the finish of the moulding itself can look pitted or have like an orange peel effect. In transparent mouldings, poorly dispersed pigments can usually show up as lack specs. Finally, one of the most important aspects of any kind of compound formulation is ensuring that it meets the requirement of the standards required in either food, toy, toxicity. So again, you need to be very careful, and this varies from country to country. So it's important that you get the right specification that the product's working to in the end.
Thank you so much, Pravin. As I said, I will be sending Pravin any replies or questions that I get for him to answer personally. There is his email address on the screen right now. In the meantime, we will be immediately moving on to the launch of our new batch of PCN product lifecycle series webinars focusing on design. So look out for those in the coming weeks. As ever, this will be on the website along with all of our other webinars in the webinar archive page. So check back for that. Before I close, I just wanted to wish you all well. Stay safe and healthy. We'll get through this. We've been through this pandemic once and the lockdowns, and we will get through it again. So just stay hopeful and stay positive. Thank you. Bye-bye.